no point establishing the aeroplane into a glide descent or a power descent if we were over Levin at 3,500 feet and wanted to get back to Palmerston North, because we will reach the ground before we're anywhere near Palmerston North, and our airspeed will be so slow that it will take ages to get back to Palmerston. So this higher speed descent is useful. We're moving forward at a fast rate whilst also descending. The 80 knots is typically more used for the approach to land. You'll remember this from straight and level flight. Climbing and descending is all about power plus attitude equals performance as well, in that we will set a particular power setting, set the nose attitude that corresponds to that power setting, and that will relate to a certain airspeed. So now it's time to talk about the factors, having talked about the forces already. We've established the airplane into the glide descent. Let's say it's 75 knots. This is a snapshot of the forces at any one moment in time in that descent. Now let's say this is on a day where it's just you and I on board, airplane's fairly light, and let's compare this with a day where maybe we've got a pilot monitoring and more fuel, so the airplane is heavier. So here we are, we've added some weight, and that means weight 1 and the forward component of weight is going to increase. And because the forward component of weight is increased, our rate of descent is going to increase. We are now going to descend down the flight path at a faster rate. We want this to still be at a constant airspeed. So if we've had an increase in those downwards forwards forces, we have to compensate that with the upwards backwards forces. So if we're descending at a faster rate, we must also be descending at a faster airspeed. And this is where you can relate it to your best lift to drag ratio. The heavier the aeroplane is, the higher that airspeed to be at the best lift to drag ratio still. So we are going faster down the slope. And that means that there will be an increase in drag. And if we resolve the new drag in the lift, we get resultant is equal to the new weight. So our best glide speed increases with an increase in the weight. The other thing to highlight here is, yes, the rate of descent has increased, so we will get to the ground in less time, but the angle of descent has not changed, okay? So our glide range has not changed. That is all conditional upon you still being at the best lift to drag ratio. Make sure you mention that. How do you prove that the angle of descent has not changed? Look, this angle here is still the same. There's been no change to that. Oops. Now the effective flap. Now you've seen on the last couple of flights, as we're coming back towards Palmerston North, I've established the aeroplane into a descent, and as we're getting close to the runway, I've set some flap. So it's important that we do understand the effect that that flap will have on the airspeed and how we compensate for it. So in this case, we've established the aeroplane into a glide descent again. We've trimmed for 75 knots. There's the snapshot of the forces. Now when we extend the flap, hey, what happened to the drag? Oh, yep, it increased. Oops, let's go. There we go. So the drag has increased, but now look, the forward component of weight is less than the drag. So what do you think will be happening to the speed? Oh, it'll be slowing down. So how do we compensate for that? Well, we could add some thrust, but in a glide descent, we're saying that there is no thrust available. So the only other thing we can do is lower the nose to manipulate the forward component of weight. We have to increase that. Increase the forward component of weight. It's now equal to the drag. And once again, the downwards forwards forces are equal to the upwards backwards forces in the aeroplane. Is still in equilibrium, still maintaining the same speed. But we're now descending at a steeper angle, so our range has reduced, and a faster rate, so it won't take us as long to descend. And we'll have a look at that in the flight today as well. There's your summary. Ask questions about that. The only other one is you might expand on a little bit is the forward visibility. So with a lower nose attitude, you'll be able to see more. The effective wind. So once again, let's say our scenario, we're arriving at Masterton, we've established the aeroplane into a glide descent, trimmed for 75 knots, we've got our altitude lost on the vertical axis, distance travelled on the horizontal axis. And here in the yellow line, we are gliding nil wind. So we've covered a certain distance across the ground, we've got a certain rate of descent, and a certain angle of descent. There's that angle there again. But what about if there's a headwind? So this time, as we descend, we have covered less distance across the ground, but we're still at the same airspeed. And as a result of this, the angle of descent is much steeper this time. So our range has reduced. What about a tailwind? What do you reckon? Ask that question. So this time, with a tailwind, we have covered much more distance across the ground, but we're still at the same airspeed of 75 knots. Therefore, the angle of descent is shallower. Our range has increased. In all cases though, our rate of descent has remained the same. So wind does not affect the rate, only the angle of descent and the range of the aeroplane. So why do you need to know about this? You may have to compensate for this on some of your flights to ensure that you are, for example, going to touch down at an appropriate place on the runway. And the way you will compensate for the wind is by using the power of throttle. So, practical stuff, that's what you have to do, right? And on a day where there's nil wind, you typically have a different power setting to a day where there is a strong wind. So there's your summary. Again, should just be questions, and that brings us to aircraft management. So there are a few new things here today. Once again, I'm going to continue transferring responsibility of aircraft management over to you. It's important for us to do engine warms during the descent if we are doing a glide descent. We don't want the engine to shock cool. So you imagine you put a dinner plate into the oven to keep your dinner warm, and you take it out and you put it in the freezer. What could happen to that plate? It could crack, it could shatter, and the same thing can happen to the cylinders inside the engine of an aeroplane. We definitely don't want that happening, so we don't want shock cooling. So if we are doing a low powered or glide descent, a good rule of thumb is every 1,000 feet of the descent, set full power briefly and smoothly just to warm the engine, and then we can bring the power back to idle again. Smooth throttle operation is important as well. During this exercise, we'll be varying the throttle position from full power to idle power. And a good rule of thumb is that we should go from idle power to full power over about 4 seconds. We don't want to be rough or abrupt on the throttle, as we discussed in the effects of ancillary controls. Monitoring temperatures and pressures is particularly important here. In a descent, we want to make sure that the engine cylinder head temperatures and the oil temperature is not getting too cold. Whilst in the climb, we want to make sure that the temperatures are not getting too hot. At full power, the engine is working hard, so it's really important for us to monitor those. Do those engine warms every 1,000 feet of the descent if it is a glide descent. But in a climb, especially if we're making a prolonged climb, you may have to level the aeroplane off every now and again to increase the airflow, give you the option to reduce the power for a few minutes, and then carry on. So there are the temperatures and pressures. Again, we should be monitoring those to keep them in the green range. We mentioned in the last briefing and in the last flight how to use the mixture. We will keep the mixture in the full rich position for climbing. We'll make sure it's in the full rich position before establishing the aeroplane into the climb. And this is because in the full rich position, when the throttle is full, extra fuel is sprayed into the engine cylinders for cooling. So there's a bit of systems knowledge you're passing on to them. During the descent, if we have leaned the mixture after leveling off, it's important for us to richen the mixture, to push the mixture forward. There's a particular ratio of fuel to air at which the engine runs the most smoothly. And as we get closer to the ground, the engine requires more fuel. So we have to push the mixture forward progressively to keep the engine running smoothly. just, real simple like that. Don't go into any great detail. We don't need to go on about how there's this stoichiometric ratio and it's so much air to so much fuel and what's happening to air molecules. That's further down the line. One additional consideration is some of the descents we've had a look at already are relatively high speed. There is a range on the airspeed indicator, and the yellow range above the normal operation speed, where we are only permitted to fly if it is smooth air. So before you elect to do a higher speed descent, you always got to make sure that it is smooth conditions. What otherwise could happen is we overstress the airframe. I want to highlight just one letter of the I'm Safe tool, and that is illness. Now, this is a lesson you really do not want to come into flight if you are not feeling well. You have blocked ears, or you've got any congestion or blocked sinuses, because we can get something called barotrauma. The pressure, or the gases, can build up inside the body's cavities, and they can cause pain during the climb and descent, which can be excruciating. So we do not fly if you're feeling unwell. You just let me know. Looking out, again, I'm transferring this over to you more and more today. There are a few additional and new considerations. When we're established in the climb, what do you think the visibility will be like? Hopefully, they can put 2 to 2 together. Oh, it's high nose attitude for bad visibility. So every 500 feet of the climb, we will lower the nose, even just briefly, to a level attitude to give you an opportunity to look down and ahead to make sure there's no hazards there, such as other aircraft, possibly cloud and traffic. Terrain. And it's important during the descent to look ahead as well, though the visibility is much better. As always, we require a clean windscreen during the pre-flight. Make sure you clean that. Situational awareness is important because as we're climbing, we may be getting closer to airspace. We've got to keep evaluating where any cloud is, making sure that we don't fly into any airspace without clearance, and we always stay clear of cloud and other aircraft as well. As you study the air law material, you'll find there are some rules around how close we can get to cloud and rules around the visibility. At this stage of your training, I just want you to know that when we're flying below 3,000 feet, above mean sea level, we must stay clear of cloud, always have the surface in sight, and at least 5 kilometres of visibility. And it changes when we go higher than 3,000 feet. So just the basics here, okay? Maybe a good resource to allow them to go home with is one of those net booklets, or even maybe not that. There's is there a little card? It's just got like the VFR net on it. Something like that would be useful, a resource they can take away and have a read of. And we've discussed airspace limitations, but we will discuss this in more detail in the pre-flight briefing. How are we going to stay clear of airspace? As I mentioned earlier, there are minimum and maximum altitudes that we can climb and descend to as well. And this you will learn more about when you're studying air law too. But it's important we're always aware of these rules. And I mentioned trapped gases already. Have a look at this slide. What type of climb do you think the aeroplane is established in? Just give them a few moments to have a look at that. So the airspeed is constant, right? So we're looking at a cruise climb here for a DA40. And that brings you to the year exercise now. So we're going to talk about how to actually get the aeroplane established into the climb. Now don't just go straight to the slide here, okay? You've got to actually paint the full picture. So we don't just go power, attitude, trim. We first have a think about what altitude that we want to climb to. We make sure that that's not going to conflict with any airspace or terrain or traffic. And we bug that altitude on the altitude indicator. And then when we've done that, we can establish the aeroplane into the climb with the process power, attitude, trim. So power, we increase the power from right to left. So we ensure that the mixture is full rich, push that all the way forward. The propeller, we set to high RPM, push that all the way forward smoothly. And then the throttle, we always set full power in a DA40 for the climb, so we push the throttle all the way forward smoothly. Now, do you remember from effects of ancillary controls, what's the aeroplane going to do when you increase the power? So, don't forget that step, because there's a reason why I haven't brought up that bit yet, because it will give them the answer. Oh, yeah, it's going to yaw. Now, what way is it going to yaw? Ah, yes, to the left. So what will you need to do? Because remember, we're trying to climb in a straight line here. So I should have mentioned that as well, pick a reference point, right? So we'll need to apply some right rudder as we go through to full power, keeping the wings level as well. Then we will raise the nose to the climb attitude. How will you do that? Ask that question. That's from effects of controls. Yep, with elevator, I'll set the climb attitude. And I'll demonstrate to you what the climb attitude looks like today. Now, right now, we've raised the nose, the airspeed's reduced to our best rate of climb, and you're feeling like you're having to pull back on the stick to hold the nose attitude there. So what are you going to do about that to make flying easier? Again, they've already learned this, so we're going to trim. So ask those questions. So we're now successfully established in the climb, having selected the attitude and held it, and we trimmed the aeroplane to remove all the stick forces. So here's just a recap on what the attitude looks like for straight and level flight, and let's compare that now with what the attitudes may look like for the different types of climb we do. So here's the attitude for best rate of climb. Notice how the horizon has moved down the windscreen. It's actually disappeared below the cowling. It's down here somewhere. So this is quite a high nose attitude. The visibility has reduced, but we're climbing at the best rate of climb. Do you remember what was achieved by this? Hopefully you remember. Most altitude, least time. It's the most efficient type of climb. So this is beneficial because it gets us to our altitude as quickly as possible, and then we can level off and reduce the power. When we climb the DA40, the fuel consumption is about 17 gallons per hour. When we level off, it could be 10 or lower. So we can save a lot of fuel by getting to our altitude as quickly as possible. What about if we pitch the nose up just slightly higher to our best angle of climb speed? Note that the attitude's slightly higher again. That horizon has moved down the windscreen a little bit further. What do you think the visibility would be like? Oh, it's pretty terrible. Really bad visibility. The airflow for the cooling of the engine is also bad. So we don't tend to climb at this speed unless we actually need to operationally. There are obstacles that we require to clear. What about cruise climb? So when do we use that? See if they remember. Oh yeah, when we're not concerned with obstacle clearance or the time that it takes us to get to our altitude. At 90 knots, take a look at that. The attitude's fairly low, isn't it? That horizon is further up the windscreen. Visibility is good. The airspeed is higher, so the engine cooling is improved. And we're actually moving forward at a slightly faster speed. So we're getting from A to B a bit faster, but we still have a reasonable rate and angle of climb. So it's a compromise between some of the benefits of the other two types of climb. And you'll find we use this type of climb quite often in your training as well. Remember that this is just an example of what these attitudes may look like. For you, it may be slightly different, and it may change from day to day slightly. So we're established in the climb. Now we need to learn how to keep the aeroplane in the climb. Now, how do we do that in straight level? There's their answer. They should be able to tell you that. Look out attitude instruments. So ask them questions about that. Okay. The only thing to recap on here is that they'll need to lower the nose every 500 feet so that they can see if there's any hazards down in front of them. And then they'll reset the attitude. So that leads you into the attitude. Make sure you've got the correct attitude set, it's being maintained. You've got the airplane trimmed, the wings are level, and you're preventing yaw. Now, because we're at full power during the climb, you will probably find you need to continuously apply some right rudder to prevent yaw because of the slipstream. So don't forget to expand on that bit. Like I said, with straight level flight, it's this bit, the attitude bit, that is actually how you maintain the climb. All right? So it's attitude with elevator, wings level failure on, prevent yaw with rudder. And then we can have a look at the instruments, the ones that are relevant. So our airspeed, we want that to be constant. Our altitude, we want to monitor that. so that we know when we're about to level off. And we've got some standard operating procedures about altitude call-outs. We make a call-out when we've got 1,000 feet to climb and 200 feet to climb as a bit of an awareness that, hey, we're about ready to start leveling off. We need to keep the aeroplane in balance, check our direction is constant, and keep an eye on the vertical speed indicator just to assess that the climb performance is as expected. And we keep the cycle going, so as soon as we finish checking the instruments, we go right back to the lookout and start again. Now we're just about to level off at our 4,500 feet, having reached the top of climb, so process for establishing the aeroplane into straight and level flight from the climb is attitude, power, trim. So about 50 to 100 feet before we get to our reference altitude, we will gradually lower the nose with elevator to the level attitude. Key word there, okay? You must say gradually, or some word that means the same thing. We often hear CCAT say 50 feet before or 100 feet before we'll set the level attitude. That is wrong. Why is that wrong? Tell me.
Level off at the wrong altitude?
Yeah. So rather than up here, it'll be there. Okay, so they do need to do it gradually. Good. Then, as the airspeed passes approximately 100 knots, we can set the desired power setting. We might set our training power setting, and we do this from left to right. So we'll reduce the manifold pressure to 22 inches. Remember, keep straight as you do that. And a little trick for you as well, you can tell your students, is actually if they reduce it to 20 inches, by the time you put the prop lever back, it increases up to about 22. Up to you whether you tell them that. It just means they've got to go back and fine tune it again. Just something that I do, it's your choice. Propeller to 2,200 RPM and then trim. And you will find that there's a fair amount of pressure required on the stick in order to maintain the level attitude as the airspeed increases. So it's in your best interest to get plenty of practice with this and be prompt with it so you're not fighting the aeroplane. So it comes back to again, select the attitude you want with elevator, hold it, and trim. We cross the ranges. We're getting close to Palmerston North. It's time to set the aeroplane up into a descent. So once again, we use power, attitude, trim. But we need to choose the altitude at which we want to level off at, making sure there's no conflicts. We'll make sure we've still got a reference point and plug to the reference heading as well. Then we can reduce the power to the desired setting. I'm not going to give you any numbers here because the setting will depend on the type of descent that you want. But when we reduce the power, we will still need to keep straight. Initially, what we need to do is maintain our altitude. So what will happen when you reduce the power? What does the aeroplane do? Yep, yours, and what else is it? Oh, pitches down. And the problem with this is if we allow the nose to pitch down, the airspeed will never reduce to the target speed. So we must maintain altitude by easing back on the stick initially, and as the target airspeed is reached, set the correct nose attitude, and then we trim. So when I hear you present this briefing in this area exercise, I want to hear that level of detail, okay? Because we tend to see CCATs just read what's on the slide, and that's not enough detail, okay? You have to really describe it. And you all know how to do this. You know, what probably happens is we take it for granted, but you do actually do these things when you go flying. And again, it comes to select, hold, trim. So what do those attitudes look like? Reference, I'm just going to skip through some of this because it's all the same process, okay? So look, there's that straight and level attitude. That should look familiar. What about a power descent, 12 inches and 80 knots? When did we typically use this? Oh, yep, approach to land. Take a look at that attitude. It's actually quite similar to the level attitude, isn't it? Not a big difference, but a lower power setting and a lower speed. What about if we want to do a higher power, higher speed descent? Why would we want to do that? Take a look at that attitude. Much lower, isn't it? Better visibility, we're going to get to where we want to go faster. You could even mention power plus attitude and trim. So power, attitude, and trim here if you really want to. And the glide descent, run through that same process, okay? Yeah, it's pretty similar to straight and level attitude. why would we use this, or when would we use this, power, attitude, trim. Right, I'm going to skip through this because it's all the same, right? Lookout attitude instruments. Remember, expand on the attitude, correct attitude with elevator, and trim, wings level with aileron, prevent yaw with rudder. You must expand on that bit. How do we exit from the descent? This does require a little bit more detail. So we need to anticipate our level off. So we typically start the level off procedure when we're about 10%, by about 10% of our rate of descent. Now, what were you guys taught? You guys taught 50 feet above or 100 feet above? Were you taught that, or were you actually taught 10%? You were taught 10%? No? That's good. Oh, just some of you weren't? No. Yeah. So it does vary. The reason we say 10% and not a standard 50 or 100 feet, actually, do you know why?
The change in rate of descent.
Yeah, so imagine the rate of descent is varying between all those kinds of descent. But what if we were also doing an emergency descent? We've just lowered the nose to a really high airspeed. You're going to need to start leveling off at way before 50 to 100 feet, otherwise you're going to have to do that, right? So that's the reason behind it. So what I like to tell my students is when they do the call out of 200 feet to descend, you check the VSI, and at that point, just quick calculation of what 10% of the rate of descent will be. If it's 80 knots, it's typically 500 feet per minute, so 50 feet, okay? So there's where your standard 50 tends to come from. So we'll start increasing the power when we're about 10% of the rate of descent before we get to our reference altitude. And we'll set the training power 22 inches, confirm that 2,200 RPM is still set, and then we will raise the nose attitude. I shouldn't say raise, actually, I'll amend that. We will set the nose attitude gradually for normal straight and level flight. The reason I amend that and say it's not raise is because actually the glide descent, the attitude may be slightly higher than the normal straight and level attitude, so you're going to have to lower it. Hold that attitude as the airspeed increases, and passing through 100 knots, we can trim fully. A little technique you can also tell your students is, because this is going to take them a while, okay, they're going to take about a minute, maybe more, in the early days to get all of this done. And in the meantime, they're going to be fighting the pressures on the stick, all right? So what you could say to them is they can trim over here somewhere, that, you know, in the airplane you tell them this, so that they're not fighting so much. It may be not too much force on the controls in a DA40, but if you ever fly Cessnas, it's a huge amount of force on the controls, and it's really uncomfortable. So if you just get a couple of winds on the trim here, then let the airspeed stabilize, and then you can fine tune your trim. You can do the same with a climb, okay? It's your choice if you do that, but I do generally find that helps students. And again, select hold trim. So then you do this, okay? This is just purely revision. This is their homework. Ask them, how do we get the airplane into a climb from straight level, maintain, level off, into descent, maintain. And that is the end of the briefing. Whew. I didn't see the time, but that was probably maybe slightly
An hour and 5, I think.
an hour and 5. Okay, so that's not too bad then. I mean, that was actually rushing a little bit through the last bit because you didn't know what to say, but you know, it might take a little bit longer than I actually assumed. I just consulted the notes. Alright, do you have any questions about any of this stuff? So, what day is it? Next Friday. Tuesday, Jess is going to present the next 2 briefings to you, so she'll be, what is it, turning and basic schools, I think, and then I will observe you who is presenting the next 2. I think it's primary effects controls and then ancillary controls. Do you know who's presenting?
Me doing.
Cool, okay, so I'll observe those, and Jess will present the other ones to you. I think that's everything I need to tell you. Yeah, any other questions? Just to really highlight the, involving the student and being descriptive here is